Good afternoon. My name is Christina Ratzinger from the Field Communication team, and I would like to welcome you to our webinar, Multilayer High Performance System for thermoplastic tapes. In the next 60 minutes, we will show you the highlights of it. Before we start, we will explain the tool, briefly introduce the company and the team, and then we will start with the show. Important for a proper live broadcast is using a LAN connection. Using a wireless LAN connection may cause interruptions. You will find a control panel on the right side of the screen. Here you can ask your questions in the chat or in the question area. Please give us a short hand signal if you can hear us. Your questions are very important to us. As soon as a question arises, you can ask it anytime. Our experts in the background will respond to all your questions and answer them immediately. At the end of the webinar, our experts will answer the most frequently asked questions live for you. I would like to inform you that we will be recording the webinar today and making it available to you afterwards. Fantastic. We have now discussed the technical points. Let's start. So that you know who you are dealing with today, let me introduce our team. Our experts, Albert Hofmann and Stefan Murauer, will present you today the highlights of our multilayer and the corresponding software, the Field Tape Studio. We are especially pleased to welcome live from Australia, Professor Bronwyn Fox from the Swinburne University. We are delighted that our CEO, Andreas Vill, will soon be opening the webinar. Frank Erlbacher and Tobias Dallinger will answer your questions in the background. Mrs. Dötzelhofer will take care of the organization, and I am happy to lead you through the webinar today. Now, I give the floor to Andreas Vill.
Ladies and gentlemen, warmly welcome here in our headquarters in Gurten. My name is Ende Phil. I'm the managing director of the company. And at the beginning, you've seen some pictures about our buildings. And I want to give you some figures about Phil. The company was founded 1966 by my father, Joseph Phil, together with 1 employee. Now we have more than 900 experts here on site, and we create in the last year a turnover about 170 million euros in different business fields like automotive, aerospace, and sports. The business fields are quite different, but there is one big common fact: the production of lightweight products with innovation from Phil. And one of these innovations we want to show you this afternoon during our first webinar in the field of composite. But I'm not the real expert. The expert is standing beside me. His name is Albert Hofmann. He's doing the sales, and he will introduce you our latest innovation, the so-called Phil Multilayer. I wish you a nice evening.
Hi, I'm Albert, and I'm standing here in front of the latest Phil Multilayer. The Phil Multilayer is a tape laying machine creating 2D near net shaped preforms. It's capable of using thermoplastic tapes. It's capable of using thermoset prepreg, zero-tech prepreg, and it's capable of using dry fabric with a thermoplastic binder veil. So it's a very compact machine. Its footprint is 6.5 by 3.5 meter. It's Siemens 1500 controlled. We have a 22-inch HMI installed, web-based, with the latest I/O link technology on board. We have a brand new software, a CAD/CAM interface. It's called the Fill Tape Studio. And this is going to be an important point to remember later in the seminar when Stefan Murauer will tell us more about this new software. So when we see the multi-layer, we see in the middle the laying zone. It's a laying table, and the laying heads is operating in the middle of the machine. We have on the right-hand side over there all electrical cabinets, the controller, and the vacuum system. And on your left-hand side, there is the material loading and the material cartridge changing equipment. So let's have a look inside the machine to the laying area. So we just entered the laying area through the operator door. On the back side here, there is an automated door for the automated unloading. So here we see the laying table. Its dimension is 1.6 by 1.6 meters in diameter. So it's made out of aluminum. It's rotatable by 360 degrees. So we control the fiber angle by rotating the table. And we have above the laying table, we have the laying heads here. In totally 16 heads are working here to produce the layup. One of those is the laying head number 3 we have here in front of us. It's guided by high precision linear axis with a linear motor and consists of the tape cartridge here. So this is the cartridge and the tape material. The tape runs through the head to the feeding unit and to the cutting unit. It's a cutting blade. We cut the tape in 90-degree angle. We have a guiding roll here and the ultrasonic joining head. So all these heads are working simultaneously, 16 heads. So let me show you the tape changing equipment on the back side of the machine. So here we are on the back side of the machine. We have here 4 drawers to load the material to the machine, and here are another 4 drawers to load the raw material to the machine. So the operator has to pull out the drawer here, load the new tape material to the cartridge, close the drawer, and the new material is loaded to the machine. In the center, we see the laying heads from the back side. So we see all the tape cartridges. And below these cartridges, we see the cartridge changing equipment. So in case the material runs out during process, the tape material is changed automatically. Or in case you're producing a multi-material layup, you can choose or you can change from one material to another material by changing the tape or the material cartridge. So I would like to hand you over to Stefan Murauer, and he will tell you more about the CAD/CAM interface, the Fill Tape Studio.
So thanks, Albert. And now we are heading over to the Cybernetics Tape Studio. This is the central software for managing and programming your multilayer. As you can see, this is a web-based application, so there is no client installation necessary, and you can use it in your usual web browsers like Google Chrome or Firefox. Even using it on your tablet like an iPad or Microsoft Surface is possible. The Tape Studio is divided into 5 subgroups. First, the HMI to visualize and control the multilayer. Over to the Production tab, where you are able to create and manage production orders. Then in the middle, there is the material database, obviously, as the name already tells, to manage your materials. The laying files where all your generated programs are visualized. And finally, the main part, the editor for program generation. In the middle, there you can see the layup table with all possible sections. As mentioned before, each section has a width of 50 millimeters. On the left hand, there you can see your geometries and your layers. It is possible to create a layup either manually or with the help of generators, which is our preferred way. In this case, you only must import a DXF file. To demonstrate the capabilities, I have prepared a demo part. This has a size of 760 to 550 millimeters, and we are going to create 3 layers with different orientations. So let's switch back to the editor and create the corresponding program. To do so, first we create our layer. I hit the plus in the layer category and select a base angle of 0 degrees. Second, I select my desired material. Then I press Add Layer and the layer will be added to the program. On the right side of the screen, you are able to change the parameters of these layers, but we will leave them for now. Next, I select plus and choose my contour file, in this case our webinar file. I click Open, and after the import, the contour is automatically placed on the layup table. If I select it, I am able to change the position of the contour, either per hand with the mouse or per value on the right side. In this case, we will move the contour to X700 and Y 250 millimeters. Here we go. Due to the big size of our working area, we are able to add a second part. So another time, hit Add Geometry, select the contour, open it, mark it, and move it to our desired position. In this case, X40 and Y minus 350 millimeters. Great. So now our layup is already complete for layer 1. To add another layer, we have to add with the plus, and this time we select an angle of minus 45 degrees. As you can see, the table rotates to the desired angle. Select the material and hit Add Layer. I'm sure you have noticed that our contours are now missing. The reason for this behavior is that we have to tell the program which contour we want to use in this particular layer. This is done by simply activating the 2 checkboxes, 1 and 2. There they are, and our second layer is finished. To accelerate the layer generation, there is also the possibility to duplicate it via the copy button. As the third layer is now an original copy, we must change the angles to our needs on the right side. For this layer, we change it to 90 degrees. There we have it. So now we have already finished our layup with 3 layers. Next step is to generate our tapes. For this purpose, we have added an automatic tape generator. First, we have to define for which layers we want to generate the tapes. In our case, we will do this for all layers. So we mark all layers. Next, hit the Generate Tapes button. There, you are able to define the axis width as well as the axis length of the tapes in relation to the outer contour of the DXF file. On top of this, there is also an algorithm inside that is able to optimize the positioning of the contours relatively to the layup table to minimize the material waste. Of course, we will activate this feature. Now, let's hit Generate. As you can see, the tapes are generated for all layers. To see the results, you can either go through it one by one to check the generation, or you are able to view all layers at once with the Preview All Layers option in the top. There we have it, all 3 layers combined in one view. If you see some room for improvement, you're also able to change something manually in the edit mode. Select the layer and simply click on the tape to either drag it, extend it, or reduce it to your needs. You can also edit multiple tapes at once by selecting more of them and do the same operations. But let's revert the changes with the undo button. So here we have it. Next step is to add welding points to the layers to enable robots or humans handling the finished part. We have also added an option for this use case. Simply hit the Generate Welding Points button on the top. You can optimize the generation to your specific needs with all of the following parameters, but we will leave them for default for this part and simply generate them. Here we go. All of the welding points are added automatically. If you want to add or change something, you're also able to do this by simply dragging the welding points and optimizing the position to your needs. At last, let's have another look on our work with the Preview All Layers options. Looks pretty well. The part is now already ready for production. So open the menu, hit Save As, and let's save it under the webinar workspace and name it Test Part. Click Save. Test part successfully saved. Now we switch to the Laying Files tab. As mentioned at the beginning, this is your integrated file browser for all of your created production files. Let's open the webinar folder and have a look on our created part. On the right-hand side, there are visualized some details about the file as well as the thumbnail of your layup. To finally add an order to produce the part, we have to switch to the Production tab. There, we are able to add an order for one or multiple multilayers. Hit the plus icon and fill in an internal order number, in our case 1, 2, 3, 4. Then select the file you want to produce. Go to Webinar Workspace, select our test part, and then fill in the amounts of parts to be produced, in our case 1. Simply hit Add, and the order for the multilayer is now created. With this step, the short introduction into the mechanics of Tape Studio is finished from my side. If you have some further questions about the functionalities, do not hesitate to ask them in the comment section. For now, let's switch back to Albert and the multilayer to see the production of our created part.
So well, now we see the just created layup. So we have a two-step laying procedure. That means in the first step, the 16 heads laser tape onto the laying table. We have a 50 millimeter tape width. In the second laying step, the laying table shifts by 50 millimeter, and the aim of the second step is to fill the gap between the first two tapes, and so creating a complete layer. So we have 16 heads with 50 millimeter width, and shifting them by 50 millimeter is in totally 1.6 by 1.6 meter possible laying area. So we have a maximum speed of 2 meters per second laying speed, depending on the tape material. And you see the joining points to fix the second layer to the first layer, and the third layer to the second layer, and so on. Each laying head is working independently of the other ones, and if a tape material runs out, so the head goes back to the loading area, and the material is changed full automatically. That provides you maximum productability. So this is the sample part, created a couple of seconds ago in the Field Tape Studio. now we have the part in front of us to review. So we see the tapes, we see the different fiber angles, we see the joining points, just to fix the tapes together. And for example, this one here is a sample for a possible multi-material layup with glass fiber and carbon fiber mix. And this here is a already consolidated layup, consolidated on the fill consolidation unit. So now I would like to switch to Australia, to Bronwyn Fox, to Down Under.
Thank you, Albert. I will just share my screen with you all. Good afternoon or good evening, as it is here in Melbourne, Australia. I'm absolutely delighted to join you all this evening to be able to talk to you about our partnership with Phil and about a brand new facility that we're building here in Melbourne. It's our National Industry 4.0 test lab for composite additive manufacturing. So as we do in Australia, I'd like to start by acknowledging the traditional owners of the land from which I'm speaking to you from, the Wurundjeri people of the Kulin Nation, and pay my respects to their elders past and present. A little bit about Swinburne University of Technology and our research. We have 5 dedicated research institutes and 15 research centres, and we're ranked in the top 2 in Australia on the basis of our offshore PhD research student program, which we're expanding at the moment. We won an award for being the most industry engaged university in research within the sector in Australia, really driving impact through our industry partnerships. And we had some very good news last week. We were actually ranked number 45 in the QS top 50 universities under the age of 50. So while Swinburne was founded actually 112 years ago by George Swinburne as an educational institution, we were given university status 28 years ago. So we're still technically under 50 years of age. Our National Industry 4.0 Test Lab is part of a national network of test labs that is loosely based on the model that is present in Germany around the Industry 4.0 test lab network there. And we have 6 that are located in Australia, and there's roughly 1 in every state. And ours is the first truly national Industry 4.0 test lab. We're proud to partner with CSIRO, which is our national science agency, and it's currently under construction in Clayton, which is just a short drive from where I am here in Hawthorn in Melbourne, about 20 minutes away. We're really proud to have a very long-standing relationship with our National Science Agency, and this has really come about as in part because of the invention of the polymer banknote. So if you've travelled to Australia, you would have seen that we have plastic money, and that was a CSIRO invention, and one of the inventors is a professor at Swinburne. CSIRO is famous for inventing Wi-Fi. They've invented flu treatments, around, as well as a raft of other technologies, and we're really proud to be partnered with them on Industry 4.0 design thinking, data science and biomaterial science in particular. They give us enormous depth in our partnership. And they have supported the construction of this building. This is a rendering of what the facility will look like. And this is an actual photo from the time-lapse camera that was just taken within the last day of the construction site as it is emerging from the ground. You can see that we have a roof on the building, we are constructing walls, and the building is due to be complete at the end of September, which will time perfectly with the arrival of the equipment from Phil, which will arrive in early October. We're very excited about that. So this is what is going to go into the facility that I just showed you. It's a fully digitalized pilot plant for carbon fiber composite manufacture. It's a lights out pilot factory where we are showcasing all of the benefits of digitalization. And we're very proud to be partnered with Siemens in Australia, who have supported all of the national network of Industry 4.0 test labs with a digitalization grant. The heart of this process is the Phil multi-layer process. And you might wonder why a university in Australia is partnered with a company in Austria. We were given advice by some of our European industry partners, and Phil has such a fantastic reputation, and we were given a sneak preview of the multi-layer process when it was still a drawing on a whiteboard, and we absolutely loved the concept. Our industry partners then did a very in-depth analysis of the capabilities of the multi-layer process and really recommended that we partner with Phil in this endeavour that we were just embarking on. So the multi-layer process is the start of our digital factory. We have a robot, a KUKA robot, that will transfer the two-dimensional preform, and you just saw Albert demonstrating that, into a double diaphragm forming machine where we Phil have automated the double diaphragm forming process. This is particularly significant because this is a really important process for the aerospace sector. The preform will be then ultrasonically trimmed and then finally cured in a press that was built and designed by Langzauner, who are also partnered with Phil. Now, this press is very, very versatile. It's capable of forming as well as resin transfer molding, and it has an infrared preheating station for processing high temperature thermoplastics, because there's been a resurgence of interest in high temperature thermoplastics. We have a number of projects to use this facility before it's even built, and that just shows the demand for this particular technology that Phil have developed. Some of the reasons that we're seeing that high demand is the capabilities of the multi-layer process to make those hybrid materials that Albert showed you, so that you can have a carbon fibre where you need structural reinforcement and glass fibre where you need to reduce cost in your particular component. One of the most exciting moments that I've had was when I visited Phil late last year in Girton in Austria, and one of our Swinburne PhD students, who happens to be based in Ulm, had sent code to the multi-layer process to print a carb on it, and it was printed in front of me, and that was a really exciting moment for me. It made me realise that we can have students all around the world and our staff all over the world sending us code to Melbourne, and we can cure parts and send them back to people wherever they are located globally. We're also really proud to be partnered with ARENA 2036, which is the industry on campus model for doing research at the University of Stuttgart. If you haven't been there, please do yourself a favour and go and check it out. It really is an incredible facility. It is a flexible, digitalised factory that's focused on Industry 4.0, digitalisation and lightweight structures. It is different every time I go there. It's very dynamic, and ARENA 2036 has more than 40 members, many of whom are really the big names in industry, and ARENA 2036 brings them together to work collaboratively along with the Fraunhofer institutes that are located nearby. So ARENA and Phil at the University of Stuttgart are important partners in our Australian Global Innovation Linkage project. We are really proud to be partnered with Quickstep, who are Australia's largest independent manufacturer of composite parts. And I've actually worked with Quickstep for more than 20 years now. And we're also very proud to be partnered with Platane, who have created some very innovative digitalisation solutions for particularly tracking and tracing materials, and they're based in Israel and working extensively with the aerospace sector. So the entire project has a value of $3.6 million, and it's focused on lightweight manufacturing of high volume composites. The project on the Australian side has triggered funding on the German side, and there are two interrelated programs of work that are being conducted. So from Swinburne, we have the physical infrastructure, and then the GIL project, which will really empower us to do projects to use that infrastructure and to train the next generation of engineers and scientists in digitalisation and lightweight materials manufacture. On the ARENA 2036 site, there are two interrelated projects. One is on production technology and the other is with the Fraunhofer IAO to create a cognitive digital twin of our physical factory in Melbourne. So there will be an enormous global exchange. These are the three interrelated projects, and we're very proud to be partnered with these organisations. But particularly Phil, who are absolutely world leaders, have been incredibly supportive and generous of their partnership with Australia. And I think more than just doing technology development, we're building a global community. And I'd like to thank all of the members of our global community from all over the world, including the US. And I'd like to point out that this picture of us all drinking beer in a Bavarian beer bar is actually in Melbourne. So you're very welcome to come and have a beer with us in Melbourne when the facility's opened. And we would love to be able to work with you. Thank you.
So what can we do for you? We can set up a video call or a face-to-face meeting to discuss your case. We can do material test for your product. We can develop the optimal solution for your request. We can do a process simulation with your part and your geometry. We can do a cost calculation of your part. And for sure, we can provide you with a quotation.
We hope you enjoyed the webinar. We are now happy to answer probably the most frequently asked questions. So let me take a look. This question was probably interesting. Mr. Hofmann, what adjustments must be made on the machine when changing raw material?
Basically, there is no mechanical modification needed. So once the material is commissioned and we have all the laying parameters stored in the database, there's no modification needed. So when the change from one material to another material, the laying parameters are loaded from this database. So in general, once the material is commissioned, there's no change needed.
Interesting, thank you. The following questions have also reached us frequently. What performance can be achieved in the terms of output?
Well, that's not so easy to answer. So we have 16 heads working simultaneously. So we have a high-speed linear axis working, and for sure it's depending on the specific material parameters which laying speed you can achieve. But to answer this question, finally, it's needed that we do a simulation on your part. So, and once we do a simulation, we can provide you with the cycle time and with the amount of tapes needed for your part.
And now I have one more question. For which part is the machine designed?
Generally for all 2D near nap shape preforms made out of thermoplastic tapes, zero texture prepreg or dry fabric. We started with the look into the automotive industry, but since we have commissioned PIC material, for sure the aerospace industry is interested in the machine, as well as sports and the building construction industry too.
Thank you very much, Mr. Hofmann, for your answers. So, your feedback is very important to us, which is why you will receive a survey email afterwards. We look forward to your honest feedback. Additionally, we will send you an email with all important information till the end of the week. You will receive the link to today's recording important product details, and contact addresses. If you would like to learn more about Phil, please visit our website or follow us on our social media channels. Our experts are always available to answer any open questions. Dear all, we wish you a pleasant day and look forward to hearing from you again soon. If you stay here for a short time, you will see some pictures of Phil to get insight into the company. Goodbye.